Hello my youngsters, welcome to Proportion with Mr. Ehige. In this topic we are going to be looking at the concept of proportion, types of proportion and application of proportion. First, let's look at the concept. Now let's look at a computer monitor screen which dimension is 40 cm by 30 cm. The length is 40 and the breadth is 30. If we are to draw this in a book, this dimension will be too large for the book. That is to say, we cannot represent it in a book. Each book is too small. So what we do is to do what we call scale down. So scale down means to reduce, alright, to reduce the value of the length and the breadth by the same amount. For example, we can decide to make it 4 by 3. That is to say, the length is 4 and the breadth is 3. So that is called ratio of 4 to 3. So if you have a bigger book, you can make it 8 by 6 centimeter. Alright, so that means that is 8 to 6. However, this ratio 4 to 3 and the ratio 8 to 6 are both from the division 40 over 30. Alright, 40 over 30 has been reduced to 4 over 3. Alright, then for the large one where we have 8 to 6, the ratio of 8 to 6, 40 over 30 was reduced by dividing the numerator and the denominator by 5. So we have 8 over 6. So the ratio is 8 to 6. But when you look at 8 over 6 and 4 over 3, they are the same ratio because 8 over 6 is an equivalent fraction of 4 over 3. Alright, so the three ratios are equal because one is an equivalent fraction of the other. So when we look at the three ratios, we discover they are all equivalent ratio, or they are said to be in proportion. Now, to conclude, when you discover fractions are equivalent or ratios, they are said to be in proportion. So 4 over 3, 8 over 6, and 40 over 30 are in proportion. Now, let's look at these two ratios, 4 over 3 and 8 over 6. We can conclude that they are in proportion. So what is proportion then? Proportion are therefore equivalent fraction or fractions that are equal. So 4 to 3 is same as 8 to 6. Alright, so both of them are in proportion. Now you discover there is a double ratio symbol at the middle. It means both sides are same as each other. So proportion means equivalent ratio and double ratio symbol means same as or equal to. Alright, now let's look at types of proportion. So there are basically three types: direct proportion, inverse proportion, and partitive proportion. Now first, let's look at direct proportion. In direct proportion, as one quantity increases, the other also increases at the same rate, and vice versa. That is, when one decreases, the other also decreases. This is what you call direct proportion. Alright, now there is another one which we call the inverse proportion. In this type of proportion, as one quantity increases, the other also increase at the same rate, and vice versa. Now let's look at another type, the final one, which is the partitive proportion. In this type of proportion, a whole is divided into parts that are proportional to a given ratio. First, let's look at direct proportion. Now, for example, 2 big cars can transport 40 people. How many big cars are needed to transport 80 people? Take note that 2 quantities here are the number of jeeps and the number of people. Note that the arrows are pointing up, showing that when the number of people increases, the number of jeeps also increase. This is an example of direct proportion. Alright, so the same way, if the number of people decreases, the number of big cars also decrease. This is called direct proportion. Now let's look at the examples. The first step is to first of all identify the quantity, as we have already done. Alright, now the quantities are the number of jeeps and the number of people. Now we try to draw a table and fix these values into the table. For example, 2 is proportional to 40 and 80 is proportional to n, where n represents the number we are looking for. So the step 2 is to set up a proportion. 2 over 40 is equal to n over 80. The next thing is to find the missing number. Alright, so to get n, we have to cross multiply. Alright, we have to cross multiply. That is, 2 we multiply 80 and then 40 we multiply n. Alright, so when 2 multiply 80 is 160, then when 40 multiply n is 40n. But we are going to ignore the n and divide the 160 by 40. Alright, so when we divide, we are going to get 4. So it means n is 4, and that is 4 jeeps is what we need to transport 80 people. Alright, it's as easy as that. Now the next one is inverse proportion. If 12 men can finish a job in 9 days, how many men are needed to finish the job in 6 days? Alright, so the 2 quantities here are number of days and number of men. The arrows are pointing in opposite direction, showing that when we want to finish the job in less days, we need more men. Alright, this is an example of inverse proportion. Now we are going to take the example proper. Now the first step is to identify the quantities, number of men and the number of days. Now we set up a table and put the values there. 12 is proportional to 9 and 6 is proportional to the letter n, which represents what we're looking for. However, we are going to swap the position of the number 12 and the letter n. Now we are swapping the position because this is inverse proportion. We don't do this in direct proportion. So we swap the position, and once we are done with that, the next step is to find the missing number, n, using proportion. So according to the table, 9 over n over 9 rather is equal to 12 over 6. The first thing to do now is to cross multiply. N times 6 gives us 6n. 9 times 12 will give us 108. All right, so once we are done with that, we try to ignore the n, all right, and divide the 108 by 6. So once we do that, we are going to get 18. So n is equal to 18 men. So that means we need 18 men to finish the work in 6 days. It's that easy. All right, now let's look at the last type of proportion, which is the partitive proportion. A glass of jar has 64 chocolates. Jeff, Leah, and Dave are to share these chocolates in the ratio of 1 to 1 to 2. Now, this kind of proportion is called partitive proportion because it involves sharing a whole. All right, 64 is the whole, and so the given ratio is 1 to 1 to 2. All right, now let's look at a partitive ratio sharing method. The first step is to add up the ratios to get the total parts. All right, and when we do that, we get a 4. 1 plus 1 plus 2 is 4. The second step is to find what one part represents in the ratio. All right, to do this, we simply divide the total, the base, 64 chocolates, by 4. So 64 divided by 4 is 16. Then to get what each person will get, we will have to multiply 16 by each person's ratio. For example, Jeff has a part of 1. So when we multiply 16 by his part, which is 1, we get 16 chocolates. For Leah, who has a part of 1, we multiply 16 by 1 and we get 16 chocolates also. But for Dave, which has a part of 2, we multiply 2 by 16 and the answer is 32 chocolates. To be sure our answer is correct, we add up these values: 16 plus 16 plus 32. That gives us 64. All right. Thanks for watching and see you in the next class. Bye.